As we introduce chapter 4, I thought it would be a fun way to learn about polynomials on this mathisfun.com webpage. So mathisfun.com is actually one of my favorite websites. I would encourage you to look at it again if you're ever struggling with a topic and just trying to understand it. Math is Fun is a great resource that puts even hard math lessons, and they have such a wide variety of lessons, easy and hard. But they do a lot of visual explanations and kind of break it down. So it's a great resource you might want to check out. So I'm going to introduce it today with polynomials. I'm going to use my little pen here as my pointer so you can make sure you can see my cursor. So polynomials, what are polynomials? Well, here's an example of a polynomial. This example has 3 terms, 1, 2, 3. And notice that it has some variables, but the variable exponents are whole numbers. Here's a 2, and this one has a exponent of 1. So a polynomial, by definition, comes from poly, meaning many, and nominal. In this case, that means term. So it really means many terms. So we can have a whole bunch of terms connected by addition and subtraction, and the variables always have an exponent that is a whole number. So let me scroll down. So some rules that qualify for something for a polynomial. So a polynomial can have constants like 3, -20, 1/2. This one has a constant of -5. It can have variables like x, y. You can have 4, 5, 3, as many variables as you want. This one has 2 variables. It has an x and a y. And it also can have exponents on those variables, but the only exponents that are allowed are whole numbers. That's the non-negative integers. So that's 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, as big as you want to go, but as long as they're the counting numbers, starting at 0. So my exponents here are, the x has a 1, that y has a 2, this x has a 1, so all those exponents are whole numbers. One really cool thing about polynomials, if I add them or subtract them or multiply them together, then I end up getting another polynomial. So it's closed under these operations. If I add 2 polynomials together, I get a third polynomial. If I multiply 2 polynomials together, I get a third polynomial. I can also divide polynomials. If I have 2 polynomials and I want to divide one by the other, I can do that and I'll get an answer, except that will not be a polynomial. So once I divide by a variable, that breaks this rule of the exponents being whole numbers. So my quotient will most likely not be not definitely, because remember, a polynomial could be just a constant, right? If I just have one term and just have that -5. But there's a good chance that when I divide 2 polynomials, that my result, my quotient, will not be a polynomial in itself, even though those 2 polynomials that went into the division problem were polynomials. Okay, so once I divide by a variable, so something like 2 over x, then it's not a polynomial. So a polynomial can have constants, variables, and exponents, but never division by a variable. Also, they can have one term or more terms, but they can't have infinite number of terms. You can pick a number as big as you want. You can say 100 terms, 1,000,000 terms, 5,000,000 terms, 1,000,000,000,000 terms, and as big as you can say a number, you can have that many terms, but you can't have infinite terms because you can never reach infinity. So let's play a game about polynomial or not. So here's another example of a polynomial. This is a 4-term polynomial. 5xy squared minus 3x plus 5y cubed minus 3. I think that little 3 right there is just a little over to the right too far. It's supposed to be on that y. So my exponents here are, let's see, my exponent on the x is a 1, and then on the y it's a 2, and then on this x it's a 1, on this y it's a 3, This one doesn't have a variable, so you can think of that also as a variable of 0. I'm sorry, exponent. I don't know. Yeah, exponent. So my exponents are all whole numbers. So starting at 0, counting numbers starting at 0. So that is a polynomial. It's got many terms and they're all the exponents are whole numbers. Now let's look at this one, 3xy to the negative 2. Negative 2 is not a whole number. It is a negative integer. So that is not a polynomial. Now let's go to this one. We got an x in the denominator. That means that this is not a polynomial. So polynomials have exponents that are whole numbers, and they have no division by a variable. So those are the two rules that just got broken here. So those are not polynomials. Okay, so here's some examples that are polynomials. 3x, that has a exponent of 1, whole number. That's a whole number, so that's good. X minus 2, x's variable is 1, so that's a whole number, so that's a polynomial. These x's this x has a variable of exponent of 1. This y has an exponent of 2, so this third one, that is a polynomial. Then going down to the fourth one, 3xyz plus 3xy squared z minus 0.1xz minus 200y plus 0.5. So I have many terms, 1, 2, 3, 4, 5 terms. I have 3 variables, and all the exponents are whole numbers. So that is a polynomial. Then I have the next one is 512v to the 5th plus 99w to the 5th. Again, I have many terms, so I have 2 terms. Both of them have an exponent of 5. That's a whole number. There's no variable in the denominator, so that is a polynomial. 5 is also a polynomial because it is a constant. You can think of it, the variable being an exponent of 0. So that if x to the power of 0 is just 1. So a constant is a polynomial of degree 0. So yes, a constant can be a polynomial. All right, now let's look at some examples of things that are not polynomials. Let's keep that screen right there. So 3 times x to the y to the negative 2 is not a polynomial because the negative 2 exponent is not allowed. Remember, the exponents have to be whole numbers. So that's 0, 1, 2, 3, blah, blah, blah. A non-negative integer is a whole number. The next one, 2 divided by x plus 2, not a polynomial because I have the x in the denominator. That means that's x to the power of negative 1. That's a denominator, a variable in the denominator is the same thing as having a variable with a negative exponent. So that is not allowed. 1 over x is in the denominator. That is not allowed. Square root of x is not a polynomial because its exponent is a fraction. That's how you express roots as exponents, is you use a fraction. Curious about that? You can actually come to mathisfun.com and check out the fractional exponents. All right, let's scroll down and see what else we can learn here. So x over 2 is allowed because I can write 1/2 and then as the coefficient and x as the variable. The coefficients can be fractions, but the exponents can't. 3x over 8, that can be counted as a polynomial because I can write that as 3/8 as the coefficient and x is the variable and the exponent is 1. Square root of 2 is allowed because there's no variable under the square root. This is actually just a number. It's an ugly number, but it's a constant. So that is a polynomial of degree 0. So polynomial means many terms. So there's a lot of different types of polynomials. We have a monomial, which means one term. So there's our one term example. Binomial, that means 2 terms. so like 5x minus 1, and trinomial, which means 3 terms. So you can remember these words by thinking about these bicycles, or I shouldn't say bicycle because that's only the two-wheeler, right? A monocycle, a bicycle, and a tricycle. Monocycle has one wheel, a monomial has one term. Bicycle has 2 wheels, a binomial has 2 terms. And a tricycle has 3 wheels, and a trinomial has 3 terms. There's also a quadrinomial, 4 terms, a quintinomial, 5 terms, but those are not often used. All right, it is also possible to have no variable at all. So we talked about that before above. We talked about how a constant is a polynomial, and it just has one term, so that is a polynomial with degree 0. You can have one variable, and you can have many terms. So this example has 3 terms and one variable, x. Or you can have many more variables. In this example, we have 2 x, y, z, 3 variables in 2 terms, and that is a polynomial. So why are polynomials so special? Was, as you can see, they have these certain rules to keep it looking simple. And then you can add them, and you can subtract them, and you can multiply them, and when you get results, you'll still have another polynomial. So we use polynomials a lot to model real-life applications of math. Even when the exact equation to model it is not a polynomial, sometimes we'll use a polynomial that's close to it because they're easy to work with. So if you add them, you get a polynomial. If you multiply them, you get another polynomial. You can do lots of addition and multiplication and still have polynomials as a result. Also, polynomials of one variable are easy to graph. They have smooth and continuous lines. So let's look what that looks like. So here's an example of a polynomial graph. You can see I can draw this whole line without picking up my pencil. That tells me it's continuous. There's no holes, there's no breaks. You can also see that it's smooth, right? I'm not making any sharp changes. It's just a smooth curve, no abrupt turns. So it's nice and smooth. You can divide polynomials like we said above, but the result might not be another polynomial. Now let's talk about the degree of a polynomial. A degree of a polynomial is the largest exponent on a variable. So if I only have one variable, then I can look for the largest exponent on that variable. When it's written out as many terms, with adding and addition, adding and subtracting between them, then it's easy to just find the term that has the highest variable, and that is our degree. So this one, 3. This one is of degree 3, the largest exponent of x. There's more complicated cases, which we'll explore in a few minutes by clicking right here, degrees of an expression. Okay, the standard form of a polynomial, you can see why this is kind of like the simplest way to express it. So with a standard form, I have many terms, and I have them separated by addition and subtraction, and I have the highest degree in front. So looking at these four terms, the highest degree is the x to the 6th. So that one comes out in front. And then the next degree is the x cubed. So that one's going to come next. And the next one is the x squared. And then the constant. So it always starts with the highest degree. And then the exponents go down in descending order. And then the constant is last. Notice there's no x to the 5th and x to the 4th term, and that's okay. You just list the terms that you have in descending order. So you don't have to use standard form. It does help to see that it's a polynomial, but as you'll see in today's lesson, When we graph them, it helps to go. This is actually general form, come to think of it. So I'm going to argue with this website just on this particular language, the standard form. This is actually the general form of a polynomial. All right, so let's now do these questions. So this is your assignment for today, to do a little quiz with these 10 questions. So you can do those on your own by going to the link on the assignment, or you can do it along with me. So I'll go ahead and do those now. So question 1, which of the following is not a polynomial? So let's see, let's look at A. Let's see, I got, well, let's think about our rules of polynomials. So I know it has to have the exponents always are whole numbers. So are any of these exponents not whole numbers? No, these are all ones. This is a 1, this is a 3 and a 5, a 1, a 3. So that rule is not broken. And my other rule is that x, the variable, cannot be in the denominator. So on this one, I have a 2 in the denominator, but x is not. So I can rewrite that as 1/2 x, so that's okay. This one has a coefficient and variables, no concerns there, and same with B. But D has x in the denominator. So which one is not a polynomial? That would be D. So we did good. So it is not a polynomial because a polynomial should not contain division by a variable. It's still a valid expression, but it's not a polynomial. What is the degree of this polynomial? The degree is the highest exponent on a variable. So this one, the only variable is x, so I can just look at all the x's, and I have an x to the 5th here, and then I'll get my little pen so you can see my cursor right here. So this must have a degree of 5. And we got it right. Put this in standard form, or general form, I'm going to say, for writing a polynomial. Oh, okay, here's our equal sign. So we were given it like this, and if you reorder it to get into general form, you do an equal sign, and then the highest degree was the 5, and then there was a degree of 4, and then a degree of 3, and then a degree of 2, exponent of 1, exponent of 0, your constant at the end. So that's a 5th degree polynomial. Incidentally, I also want to give a little vocabulary. Once you get it in that general form with the highest exponent in front, then that 3 is the leading coefficient. So to find the leading coefficient, you look for the highest degree. So here that's x to the 5th, so 3 is the leading coefficient. All right, next question. Which of the following is a polynomial? So again, I don't want any negative exponents. So I see a negative exponent here, so B is out. I see x in the denominator in D, so D is out. And A, I see a 2.5, and a 1/2. So 2 fractional exponents, so A is out, so that leaves us C. Okay, question 4. What is the degree of the polynomial? So I'm looking for the highest power. This is a little trickier because I have an x and a y. So I'm actually going to look at each term and add the degrees, the exponents together to get the degree. So for example, this negative 4x cubed y, that's a degree, that one has degree 4. So x has an exponent of 3, y has an exponent of 1. So I add those together and say this term has a degree of 4. This one has a degree of 4. This one has a degree of 5. The 2 plus 3 gives me 5. This has a degree of 4, and the 2 has a degree of 0. So my highest degree was the 5. So how many terms does the polynomial 3x to the fifth minus 2x cubed minus 4x plus 7 have? How many terms? So terms means count between the minus and the plus signs. So that's 1, 2, 3, 4. If f of x and g of x are two polynomials, which of the following may not be a polynomial? So remember we said that it's closed under addition, subtraction, and multiplication. If I do those three operations, I'll get another or a third polynomial. But if I divide them, then if there is a variable in g, then I don't have a polynomial anymore. So division, the quotient may not be a polynomial. Okay, so now we're writing this one in general form. So that means that we want to put the highest power in front. So it looks like our highest power is a 5 and the coefficient is -4. So it should start with a -4x to the fifth. A starts with a +4, so that one's out. C starts with a constant, that's out. D starts with a constant, so that's out. So that just leaves B. I don't even have to check the rest of the polynomial, but I'll just kind of glance at it. Make sure my exponents are in descending order, 5, 4, 3, 2, 1, and then the constant. So that's B. So which of these polynomials has a degree 4? Let's see. Oops, sorry. So this one has a degree 4. Yeah, A is good. C, degree 4, yes. D has a degree of 2, right? There's a 2 there, and if I add the x and y exponents, I still get 2. So D is out. D is not a degree of 4. Could be B, so could still be A, B, or C. Let's look at the next thing is 3 terms. Okay, well, A has 1, 2, 3, 4, 5 terms, so that one's out. B has 1. Whoops, I did not mean to select that. Oops. All right, I was trying to just point. So this one has 3 terms, and C has 3 terms, so it could be B or C. But then my third requirement is that it has only 2 variables. And notice with B, I have only 1 variable, just the x. So it must be C. That's the only one that has degree 4, 3 terms, and 2 variables. Which one of the following could be a graph of a polynomial? So remember, our polynomial graphs are smooth and continuous. So this one is not continuous. Remember, continuous means I can write it, I can draw it without picking up my pencil. But how am I going to get from there to there without picking up my pencil? Same with C. C is not continuous because I have to pick up my pencil to go from here to here. B is continuous, but it's got a sharp turn right there. Sharp turns are not allowed, so it's not smooth. D is continuous and it's smooth. So the correct answer is D. Which one of the following could be a graph of a polynomial? So again, I have a break here. I cannot draw this line without picking up my pencil, so that is not continuous. This one I have an asymptote. I can't draw my line without picking up my pencil, so that one is not continuous. B is continuous and smooth, so that looks like a good prospect. D is continuous, but right here you got a sharp turn. So there shouldn't be any points or cusps. So that one has a little cusp right there, so that one is not a polynomial. So it must be B. All right, when you finish all 10 questions, I'll have you click Quiz Results, and then you'll take a screenshot of your results. If you get less than 10 out of 10 correct, then you can go ahead and try the quiz again. Try to get 10 points. So you get 10 points for this assignment. So click Quiz Results, which I'm not going to do right now because I want you to be able to get those results on your own and screenshot on your computer. So click the quiz results and take a picture of your results to show me you did all 10 problems correctly.